Hello. Hi, my name is Elio Damaggio. Welcome. Today's talk is about Azure push notifications. I want to start this talk trying to highlight two main points of Azure Notification Hubs. That is the service that provides push notifications in Windows Azure. The first is that this is a technology that allows you to push notifications from any backend to all mobile platforms. Any backend is in the widest meaning possible, meaning technologies, so .NET, Java, PHP, Node, deployment-wise, cloud services, VMs, web services, websites, and mobile services. And of course, from your cloud, Azure cloud, non-Azure cloud, and on-prem. And all mobile platforms, that means all major mobile platforms, iOS, Android, as of today, Kindle Fire, and of course, Windows Store and Windows Phone. Also, with Azure push notifications, you can send push notifications both to single users, single devices, very targeted push notifications, or millions at a time. So this is not a technology just for broadcast. This is a technology for all your push notification needs. Before we start, I wanted to see like a little raise of hands. Who is familiar with push notifications? Great. How many people use notification hubs before? Okay, so this is the agenda for today's talk. We're gonna start saying why do we need notification hubs. So push notifications are known by everybody. They're hard. And why do we need a service that helps with that? What's new? We're gonna go very quickly on a quick start on how to send targeted notifications, how you can get up and running in 5 minutes, sending push notifications to millions and to interest groups. Then we're gonna step up our game and gonna say, yes, I have more complicated needs. How do I start to managing these devices from my backend? How do I take it to the next level? We're gonna quickly talk about templates. I'm really trying to cram a lot of material tonight. I'm sorry, I know that it's 5:30. Many people are probably jet lagged too. We'll try to keep it fun. And then we're gonna go to a couple of advanced scenarios. Push to sync and retargeting. Those things are gonna be more advanced scenarios. What you can do with push notifications, what are the things that are more, that are less obvious for the technology. So first thing, push notifications are essentials in all apps. Most likely, you guys are here because you already know this. For consumer apps, they are richer than texts. You can brand them. They do not come from strange phone numbers. You can do more things than just a text. They can be interacted with as a much better user experience. And they also ends up being tens of thousands times cheaper. And that's not just a number there. That's actually real price. For enterprise apps, that's also very important. You want to keep your users up to date with the business. And also, they're not only for alerts, they're not only for things that appear on your phone or your tablet, but they're also to provide a much more responsive experience to your user with a pattern that we usually call push to sync. So mobile push is everywhere. Of course, breaking news, your CNN apps, your NBC apps, and so on. SMS replacement in the banking industry. You want to send the current account balance, or has been a transaction doing multi-factor auth. The experience that you can provide with a push notification is a lot better than the one you provide with text, and it's also cheaper. Healthcare, you can remind people of prescriptions, you can send offers or appointments, and so on. And it goes on. Airlines apps, discrete manufacturing, and retail. So what is the push notification lifecycle? Here I will probably go a little bit fast because everybody seems to be familiar with it. The device contacts a platform notification service. And every platform has its own. The interaction is slightly different. As a result of this interaction, the device obtained some form of temporary address. So you have, we usually call them handles or channels. They're called channel URIs in the Windows platforms. There are device tokens in the Apple World. There are registration IDs for Google Cloud Messaging and the Amazon device messaging. And then once you have this handle, you have to store it somewhere in your app backend. After you've done that, when you want to target that device, you have to retrieve the correct handle and use it to send us a specific push notification. This means that you can target only a single device at a time, and you're actually targeting that specific device. It's not done yet, meaning that these channels and these handles are all transient. They're not like a phone number or an email address. Those things cannot be used to identify the device, cannot be used to identify the user. These channels are transient, so they can expire, and they can expire independently of people uninstalling your app from their devices. So you need to maintain this big registry that now you have in your own backend. Of course, the challenges that come from this life cycle are multiple. The first one is of course platform dependency. Now you have to, if you have a multi-platform app, which is very, very common, you have to handle multiple platform notification services. Your big registry now maintains multiple kinds of handles, each one with its own life cycle. And also when you send a notification, the kind of payloads and the protocols are different. Then you have routing problems. You have essentially this big registry that you're building in your backend needs to be associated with maybe users or interest groups or something that actually makes sense to your app. Nobody talks about device tokens or channel URIs in their app. You usually have app-level concepts like users or interest groups. And of course, scale. Once you have tens of millions of devices, you end up having to maintain tens of millions of handles at scale, and everything has to be very responsive. This is particularly critical if you are in the breaking news or very responsive, very fast notifications space. If you want to broadcast a push notification to, let's say, 10 million devices in a couple of minutes, you cannot just run a for loop with a select from a single table. That's not going to cut it. So why use notification hubs? First thing, you create one notification hub inside of Windows Azure. You configure with your PNS credentials, your Apple cert, your package set, and client secret for WNS. And then you basically store the handles, so the channel URIs and the device tokens, inside the notification hub. And this means that the notification hub becomes your registry, your device information registry. Of course, we do support all the various platforms. It's just to have an idea that there are many of them. When you send one notification, your app backend, which could be in the cloud, could be on-prem, could be anywhere, sends a single message to Notification Hub who knows, your Notification Hub knows which platform is each handle for, and contact the correct platform notification service with the correct protocol. So you do not have to worry about that. It also does fan out, meaning that one message going in can result in potentially millions of notifications to the platform notification services. Of course, the advantages are cross-platform, of course, from any backend to any mobile platforms, like we said earlier. You do not have to store device information in your app backend. This is something that it's very, very unlikely to happen for an app, that it wants to store device information. Usually apps do not care about devices. They usually care about users. They do not want to know that each user has one phone and one tablet and one desktop app. I mean, that's not part of the app business most of the times. Sometimes it happens, but it's very rare. We also solve routing and interest groups. With the use of tags, you can basically quickly associate device to individual users and interest groups. So you do not have to handle that. Your app just has to refer to devices in terms of interest groups and in terms of users. We do support the personalization and localization with the use of a feature called templates. We do broadcast at scale, and we also provide way to send to small groups and to single devices. And we provide rich telemetry for push notifications. So a couple of case studies. First is Bing apps on all the Windows devices. News, finance, sports, and travel, they all use notification hubs to send push notifications. They're pre-installed in all Windows devices. There are tens of millions of devices. We cannot really disclose how many, but I can say tens. We send routinely more than 3 million notifications per day, and they're delivered in less than a couple of minutes. So breaking news have to be breaking news. We also powered the Winter Olympics results app on Windows Phone, iOS, and Android. There were hundreds of interest groups. So in here, the capabilities of being able to send notifications to interest groups was really of paramount importance. The interest groups were countries, disciplines, athletes. You could subscribe to a specific game. And the notifications were routed to only the devices that were interested in that specific notification. They were localized too, using templates. The backend did not have to remember which device was subscribed for which language. There were more than 3 million devices across all platforms. And by the time the games were done, we had sent more than 150 million notifications. So what's new, since many people never use notification hubs, I was here presenting notification hubs 1 year ago. In the meantime, we added Kindle. We now support iOS, Android with Google, Android with Kindle, and Windows Store and Windows Phone. We added tag expressions. Not only you can send to a single tag, but you can actually send to a Boolean expression of tags. We will see how that is very useful. We announced today the new update of VS 2013 includes notification hub support for send notifications in the Server Explorer. We delivered a public preview of the integration with mobile services. If you use mobile services, Notification Hub is really integrated in the experience. It becomes a lot easier to go in the advanced patterns, and is really like a great experience to use. We changed the pricing model. Right now is just push-based. There's no active devices. It's just by how many pushes you send. And we also have a private preview for bulk registration management APIs that is available for customers that are interested. So let's see how this works. OK, so let's take a look at the portal. First thing, you can create a notification hub under App Services, Service Bus, and Notification Hub. Let's create a new one. Let's create this in West US where I already have a namespace. And here is my Notification Hub. I have already one configured here. This is the dashboard. You can see, let's see, maybe I already have, there's something that I did. Yeah, Okay, here you can see incoming messages, registration operations, messages. There are a lot of telemetry. There are some usage overviews, how many pushes were sent, API calls, active devices, and so on. In the monitoring tab, you have access to a rich set of metrics. So for every PNS, you can know which outcomes were output and when. In the configure tab, this is where you put the credentials for your PNSs. Here you see I have WNS configured. There's Windows Phone, there's Apple, there's Google, and since I think half an hour ago, Amazon device messaging too. You also have a chance to send debug test notifications to see directly from the portal, so you do not have to create like a console app anymore. It's really right there. Now, I have here an app, which is basically just a blank app. The only thing that I did was that I associated this app with my app in the store. This is because that procedure not require multi-factor auth. I didn't want to test my luck too much tonight. So what I'm going to do here, I already downloaded the NuGet package, but otherwise I still have to do everything. I go in the app manifest. I am going to set this app to be able to receive toast notifications. Then inside my app, I'm going to create one instance of a notification hub class. This is basically the client that is going to talk to the notification hub. And then in onLaunched, what I'm going to do, I'm going to instantiate this class. My notification hub is called build 2014, and then I have to put my credentials. I get this from the portal. Connection information. I'm going to select the listen credentials. I do not want my app to be able to potentially spam all the clients in my that install my app. I'm going to create a new, here it is, a new async method. And here, what I'm going to do, like we saw in the graph before, in the chart before, I'm going to ask for a channel from WNS. And that was mindful. Okay. Here I get my channel. Once I have my channel, I basically have to store it in my notification hub. How do I do it? I basically use my hub that I already configured, and I register for native notifications. And here, I'm going to set my URI. Now we can set a breakout point and launch this app. So if everything goes well, we should arrive here at my breakpoint. We have the channel. This thing is the big channel URI, the transient address of this app on my machine right now. And now I'm going to store this in my hub. Okay. Now let's look at the VS integration. Here in the Server Explorer, if you install the new VS update, you're going to see your notification hubs. And in particular, we're going to see this one that we're using, the 2014. Right-click, we can send a test notification. We're going to broadcast to everybody, and we're going to send a toast message. If everything goes well, this should arrive, and it arrived. So this is effectively all it takes to send a push notification. Now, this push notification is going to be broadcast to everybody on my app. So with the code that you just saw in the appxaml.cs, we basically wired up this app to register in the notification hub, and all the various instances of this app are going to refresh their channel URIs in the notification hub every time they start, and from your backend or from your website or from whatever you want, you can effectively send a push notification to all the instances telling them that, I don't know, like a new version is out or there's a new breaking news or anything like that. This is everything that it took. Okay, let's go back. Okay, so this is what we did to register, right? So we had our hub, we had our channel, and we registered. Same things you can do in iOS. When you register for push notification, you register your callback. Did register for push notification with device token, for people familiar with that. You instantiate your hub, same inputs as we saw before, and then you register native with device token, and you pass the device token that does the same thing. In Android and in Kindle, it's the same idea. You have a hub client. As soon as you get your registration ID, you pass it to the notification hub, and you're done. To send the messages, you, of course, do not have to do it from Visual Studio, but that is the code that sends a push notification to all the clients in your notification hub. So you put in your toast with the XML format that you want, and this is how you're going to do it. We also have, inside of Node and mobile services, we even have like better ways to craft that XML, but essentially it's just XML. Everything that you give us, new templates, everything, all the XML that Windows supports, we pass through. We do send, of course, if you specify the format, and you want, when you want to send to iOS, you have to send us the iOS payload, so the JSON that APNS wants, and same thing for Android and Kindle. So let's see how we send something that's more targeted. Right now, people say, usually it's like, well, I'm just doing broadcast. How do I actually send a notification to a user? How do I actually build a real app? Okay, so the idea is that you use tags. Tags are just simple strings that you attach at the moment of registration. So when the device registers, they can specify one or more tags. In this case, we have one phone that is specifying whalers and one tablet that is specifying beetles. What happens is that when the app backend specifies one tag, it reaches only the devices that have the corresponding tag. You can use tags for multiple types of interest groups. They're just strings. You can have follow bands or follow user in the enterprise space, organization IDs, work groups. You can also use them as user IDs to tag all the devices of a specific user. How do you register for tags? That is the same idea. The same code that you use to register for broadcast, you basically use to register for tags. You just add the tags. Same thing for iOS and Android. So this is a question that I always get. I can register for my tags, but how do I read them? I put in all these tags, but I want to see what I was registered for. Okay, the short answer is that you should not read your tags from the hub. The thing is that the notification hub deals with your device registrations, your device information. Device information are transient. So people can uninstall their app, the handles expires. We did not want the developer of the app to have to do cleanup on their device information. We did not want you to have to do, to make sure that you didn't have like registrations for devices that were no longer there. So what we do is that we expire the registrations automatically. What this means is that Notification Hub is not a storage system. So we store device information as long as those devices are actually users of your app. You have to maintain a single source of truth for your tags, which is usually something that pertains to your specific app. It can be associated to a user. It can be associated to other things, but usually is something that pertains to your app. It can be done in the device. You do not have to maintain it in the cloud. And actually, mobile platforms are very rich. You can use it in local settings for a specific phone, but every platform has already cloud storage readily available for you for the user of that app. There are roaming settings in the Windows platforms. You can use iCloud in the iOS world, so that you're sure that the same user actually is storing the tags and the preferences across all his devices. You do not have to rebuild it on your own. Of course, sometimes you actually do want to have that information in your backend, and when that is the case, you have usually an ID that is a user ID. You do not want to keep track and keep tabs on everybody's phone. People change phone very frequently, or they have more than one, or tablets, or installation on different computers. This is why the register methods always override the tags. So each time that you update the channel, you basically refresh with the set of all the tags that that specific device has to have. Now, let's look at this example that clarifies a little bit how this works. Okay. This is an app that, very primitive app, that allows you to subscribe to different kind of coupons. Now, in here, you see that I'm already subscribed to beauty coupons. That is because I have it stored on my local storage. What happens is that I can subscribe for other things, let's say food, and when I subscribe, what's happening is that I'm going to the notification hub and I'm specifying two tags, one for my food coupon and one for my beauty coupon. Now, what happens, of course, is that I can send a beauty offer. Well, and this should arrive. I'm sorry, my session is not that fun. Anyway, I wish next time I have to get some music. Anyway, what happens here is that when I click that subscribe button, what I did is that I put all this. I created a list of tags, and I used this notification object to store the categories in my local storage and to register to Notification Hub. Now, what does this class do? This class has a reference to the Notification Hub that, of course, is instantiated with my credentials and so on. In store here, I just store everything in my local settings. I could put them in the roaming settings so that if I install the app as my user on another PC, I would still have all my tags there. And then I actually subscribe. I get my channel, I register, and then register for the categories. This is a very simple thing. Now, let's see here. We can add something. Not all tags actually come from user preferences. I could have like some tags that are just part of the system. Maybe I want to send notifications only to tablets, or only to phones, or only to the Windows platform or the iOS platform, or a certain client version. So what I can put here, I can put here tablet. And of course, I have to register for tablet. So of course now when I send my, when I subscribe, I'm going to add another tag that is my tablet. Now I can target it when I send one notification, and maybe I want to send this beauty offer only to tablets. Of course, now this is going to reach mine. Now I want to send a food offer only to phones. And of course, this time, it will not going to be there. So what did we see here? Tags can be both user preferences or system information. You have a lot of freedom. With tag expression, that freedom is it's even more, because you can really combine the two aspects of it. There are like many uses that you can use for tag expressions. So you can do everybody except me, for instance. You can do for events. You can make sure that people that are subscribed for multiple interest groups that pertain to the same events just receive one notification. When there is like a touchdown of two teams and a lot of players that were involved in the action, if I'm subscribed to Team A and player 1, I still have to receive the notification once. You can use it to specify the time zone and to make sure to send notification only for people in a specific time zone. So here you want to send something at lunch, but only when it's lunchtime here. So you can send that food coupon only to people that are only around lunchtime, and make sure that you're not bothering people at night. You can also use them for versions and platforms and so on. So we did see how to get started very quickly with tags, how to have a very quick way to send push notifications to interest groups. Now we want to step up our game and see what does it mean to manage the devices from your backend. When do you have to do it? It seems that you can do a lot of great things just by using the Notification Hub's device SDK, registering for tags, using the platform roaming settings and cloud settings to be able to provide even a better experience that didn't require anything from your backend. Technically, you could send the notifications from your laptop. So when do you exactly want to register from your app backend? There are basically like two main scenarios. The first is when tags have to be secured. You saw that we put the credentials in the mobile app. That basically means that anybody can register for any tags, because the Notification Hub doesn't know who's who and doesn't know who's authorized to subscribe for which tag. This is sometimes problematic if you're sending personalized or really individual and kind of sensitive information to a specific user. You do not want somebody else to subscribe for your own user ID. In this case, you might want to route the registrations through your backend, which means that you do not put the credentials in the device anymore. You have them stored safe in your backend, and the device has to call your backend to effectively register for a specific tag. In that case, you can perform auth, you can add tags maybe, depending on other characteristics of the user, and so on. The other scenario is sometimes the backend has to modify tags. This happens when the tags can change for things that do not depend on the device. So what we saw right now is the user on the device that is changing something. I want to follow the Yankees and not the Red Sox anymore, and so on. This sometimes you want to modify a tag because of actions that happen on another device. So I modify something on the app, on the web version of the app, and I want the change to be reflected on my phone. or as a result of other users' action. So a manager might be adding an employee to a work group. So the employee phone had nothing to do with the addition of that tag. Sometimes also tags can be derived from analytics or other user data or CRM systems. Now a certain person is platinum and not gold, or is losing the gold status. So how do you register from the backend? The first thing is that you need a way to identify your device. You do not have the Notification Hub's SDK on the device anymore that does that for you. And also, you cannot use the channel URI and the device token and the registration ID. Those things are transient. They're not device IDs. They can change at any time, and they should just not be used to identify a specific device. The solution is basically to keep a long-living registration IDs that the Notification Hubs provides on the device storage. Basically, what you do is that you store something on that device that says, hey, this is the registration that pertains to this device. So what you do is that the first time only, so to create this ID, you go to your backend, which relays the request to the Notification Hub to create this new identifier. This doesn't create a registration. You're not providing the channel. This actually doesn't have any side effect. What you're doing is that you're just creating your own, let's say, Notification Hub address. You're creating like an ID for your device. You're stamping your device. And then you have to store it on the device storage. That has to be like a safe thing. Then, using this ID, you keep updating the information for that device. So effectively, the Notification Hub is giving you an ID for that device. This, by the way, is the same thing that the Notification Hub SDK does for you, but this time you do not have the SDK anymore, and you have to do it yourself. When you do this pattern, though, the app backend is in the middle. So now you can perform auth. You can make sure that everybody that registers for a tag is actually authorized to register for a tag. And also, I want to note that nothing is stored in the app backend. You're not storing device token. You're not storing the channel URIs. You're not creating a table. This is just a runtime thing to do the check. So another option is when the backend wants to change a tag. So in this case, you still have to identify a tag. So in the first scenario, we still had the pattern where the device was updating the tags. But now what happens when the backend wants to update the tag as a result of another user's action or an action for the same user but on another device? So what you do is that you tag the registration, you tag that specific thing with a user ID that pertains to your app. So still, you're not going to go and retrieve the device token or the channel URI or anything like that. You're going to use an identifier that pertains to your app. So you're going to get the registrations for a specific user from the backend. So let's say my manager wants to add me to a work group. The app backend is going to take all the registrations for my device and is going to add all the tags. And again, there's no device information involved. The Notification Hub is your store for the device informations. Your app is managing users, your app is managing interest groups, but not devices. Let's see how this works in practice. Let me close here a couple of apps. Okay. Let's start with the backend here. I have a very simple register controller. This is a web API. Of course, it can be developed in any technology. This is just your own backend. So if you're using Java or PHP or Node, this is the same thing. What this register controller does, it has a reference to the hub, And we see here that the hub is instantiated with the connection string. So this time, the credentials are in the backend, so the device has no way to communicate to the hub. And then it has a couple of methods. The first one creates a registration ID. You see there's no storage involved. I receive a post, I go to the hub, I get my ID, and I return it back to the device. And then I create or update a registration with a put. And this thing can actually, in here, is not really doing anything. It's just actually creating or updating the registration. But here you can put all the custom code to make sure that the device is authenticated. You might want to inject some tags, that the tags that are, which means like adding some tags to the device that did not specify. You can go and check maybe on the Active Directory record if you want to add some other tags depending on their user graphs and so on. What it does here is that it checks the platform and creates the correct registration, uses the ID as the registration ID, adds the tags, and then creates or updates the registrations. Now, let's see the app. First we have to start the backend. The backend is starting. OK, it started. Hopefully, no, why? Well, why you're not working? Anyway, sorry? Yeah. Yeah, it's still not working. Yeah, it's running. I cannot put the breakpoint, but effectively, let me add. Sorry? Well, my bad. Okay. Let's start the Windows app, but effectively. Okay. Okay, it's just very slow. I'm going to subscribe, and what this thing is going to do, okay. Okay, they were there. Okay. Anyway, yeah, I'm actually, this is the RC of Visual Studio, so there could be things that should not have happened. Anyway, you see that the first thing that the app did is that it tried to create the registration ID. So we came here, we're creating the ID, and we're returning the ID. The ID gets stored, and then is going to create the actual registration. I create a registration, I have the tags, I have 2 tags, I have my food and beauty, and then I registered. Now let's see what happens if I remove my beauty coupons. What happens now is that the registration ID is not called anymore. This is because now that app has that registration ID. You have to be very, very careful to keep that registration ID because that is the stamp of that specific app installation. If that gets reset or lost, or you're not actually storing it, you might run the risk of having like multiple registrations for the same device, which can result in duplicate notifications. So in this case, everything is handled correctly, so we go here. Now, this is really, really very easy. What happens is that in our notification class, that was our client in the previous one, instead of having a reference to the notification hubs and the credentials to the notification hubs and so on, we just have a register client. Everything is the same. We still store in the local settings and so on, but instead of registering with the hub, we register with this register client. This register client is a client for my backend. So that is my local endpoint. And what the registration does is that it makes sure that I have the registration ID with this method. So if I do not have it stored, I generate a new one and store it. And after that is done, I basically just update the registration. Now, there is a little bit caveat here, meaning that sometimes the update registration can return 410 gone. So the registration ID can expire. This is like a safety mechanism so that sometimes things can happen that the registration IDs have to move. So when that happens, you just create a new one and go on. Okay. Now let's go back here on our slides. So everything that we saw here is actually part of the integration with mobile services. So if you use mobile services and the integration with notification hubs, all this infrastructure, the registration ID, the storage, the endpoints is already done. You have a chance of just filling the callbacks for the code that you really care about, which is that authentication there. If you use the .NET backend, you can just inherit, I think it's called iNotification Handler, and what you get to write the code that was at the beginning of that put call, and everything else is handled for you. You just call register from the device using the mobile services as SDK. It's really, really very easy. Okay, let's quickly look at templates. I'm trying to go more on the more advanced scenarios. For templates, templates are a notification hubs feature that allow you to take the presentation concerns away from the backend. Up until now, we basically saw that the backend has to send a Windows-specific payload, which effectively means that you have to send an iOS-specific payload, and a Windows Phone-specific payload, and a GCM-specific payload, and a Kindle-specific payload. So lots of specific payloads. So what happens is that there is a way to turn everything on its head. So when devices register, they can actually specify what kind of payloads they want. So you see in this case, we have a Windows tablet that is registering for a toast, and instead of the actual toast, it's putting an expression, the dollar message. We have an iPhone that's doing the same thing. It's specifying that it actually needs a JSON payload with a dollar message in the alert property. When you send a notification, you can send a platform agnostic notification. It's just a property bag. And what Notification Hubs does, it goes at scale through millions of devices and creates the special payload for each of them that each of them requested. Of course, you can specify multiple templates for each device, and you can label each template with different tags, so you can basically decide where to send your notification. Templates are also being used for notifications. So this is how the Winter Olympics app solved their problem. The client apps can register for personalized, with personalized templates. So this specific Windows tablet is registering for news in English, and this iPhone is registering for news in Italian. You see that the properties are different. One is news _en, and one is news _it. When you send one notification, you send both payloads, and Notification Hubs takes care of crafting the correct payload for each device. Not only single property, you actually have a simple expression language. This really can take the whole personalization to a whole new level. You can really make sure that you're crafting, that you're able to exploit the best feature of each platform. You can send like a message that is one single line, maybe for an iOS alert, but is actually breaking down in a couple of different fields for Windows platforms, things like that. Let's go on the advanced scenarios. I have the clock ticking here. Push to sync. Push to sync is the name of a pattern that basically is is a pattern that is used when you do not want to show a message to the user. You send a push notification to update the app state. This is one of the things that are less known about push notifications. You can send a push notification, not show anything to the user, and still do something useful. We have here one example of a music app. So let's assume that I change my playlist, my favorites, on my desktop. What happens is that I'm adding a new song. The backend can send a push notification to my phone, which then can start downloading the new song. When I go in the app, the song is already there. These are the things that you have to do to create a responsive experience for mobile apps. You cannot just have the app thinks that it's on the internet, that you open the app and you create a new connection to your backend and you start downloading stuff, because that doesn't work. This is, of course, very platform dependent. For the Windows platforms, only lock screen app can actually receive push notifications when they're not active. In iOS, since iOS 7, this can be done with some limitations. You have limits on how much network you can use, how much CPU you can use, but you can provide like a very great experience with it. Android and Kindle, as far as I know, have no limitations for those things, but of course, if your app is not respectful, it will probably be uninstalled. There are two other variants, rich push and secure push. So in this way, you're actually showing something to the user. But the idea is to deliver content directly from the backend. This can be for multiple reasons. Maybe you cannot send it through WNS, you cannot send it through APNS. Why? Because it's too big, or because you don't want to for security reasons. So the idea here is that you send a push to sync to the device that actually just contains an ID, something that's not sensitive. And then you can download the actual message from the device. So the app is maybe have to have a long-lived authentication token, but it can use that to make sure that that is the correct app. You can, if that's not present, you can actually show something to the user and say, hey, you received something, give me your credentials. You can also make sure to download media and to craft like a better experience. We have the same platform differences as above, and of course the secure push has to use some long-lived in order to have like the same experience. Here, let's look at very quickly at a small, short demo. Okay. Since we do not have the time to learn anything new, this is the same app as before. What I did here is that I added a listener on the push notification received. What happens is that when I receive a message, a notification, I assume here that is a toast, but you could send a raw notification to. What I'm doing is that I extract a parameter, which I'm putting in the launch attribute of the toast, and then I'm changing the value of the text field with this retrieve secure notification, which actually goes back to my backend and retrieves the real content given the ID. That is doing authentication, has to do whatever it needs to provide secure content. And then I create a new toast with a real message, and I cancel the old one. So let's start this app. Okay. And what I'm doing now, I am creating a new toast notification that has a specific launch parameter. That is, in this case, my ID. 1, 2, 3, 4. Now, what is going to happen now is that instead of the actual message, which was test message, something else arrived. So I completely transparent to the user, I was able to go to my backend, get the correct message, and show it. That message never went through WNS. Okay, now let's assume that we want to try the rich push. What I did, I create one extra page. This is a great offer page. It has a web view. I can show a whole bunch of rich content, I don't know, video, whatever we want to show there. And what we do now is that instead of all this stuff, it can go away. What I'm doing now, if I find it, okay, here it is. This is just a dispatcher to open a dialog. I basically just open a dialog to the user saying, hey, there's a great offer for you. And this can be a toast if I'm not there. So if I'm a lock screen app, I can show a toast. I can show an alert in iOS. But effectively what it says is that it says, do you want to go to this new page? And this new page is actually shown in this show rich push, that it's here, and that it just navigates to my new push passing the parameter. So what I do now is that I send, again, a new notification. In here, we're just putting a URL, which can be on my website. This is just going to be Microsoft. Oh, sorry. OK. Now this can be closed. I have to launch my app. So I have to register the new handle, of course. And from here now, okay, now if everything goes, okay, here it is. When I learn more, I should get, there's a missing W. I knew it. Here it is. Let's try again. Oh. Ah, okay, too many. Okay. Anyway, and now it should work. Yes. Okay. So in this way, you can actually retrieve rich content that is from your web service and provide like an even better experience for your users. Okay, I have 1 minute and 50 seconds. There's no way. Anyway. Let's try to make it. This is a retargeting scenario. Retargeting is usually like a marketing term. It's like you send an offer, and then given on the effect of that offer, you basically send it again, sometimes to a different target, like doing some different filtering. Now, why are we talking about this? It's mostly because it uses all the various patterns that we talked until now. So you send a targeted coupon. So you set the tags for user preferences, for location, for system properties, time zones, loyalty status, gold customer, things that come from your CRM or data management platform. Basically, you put everything in your tags, how we saw before. So the device sets the user preferences and the device tags. The app backend can update them depending on what happens. Then you can target a specific offer with a tag expression. People in San Francisco that are interested in food coupons. What happens is that now you can use all the rich push technology and the push to sync to have like a great experience there. You can show an HTML and whatever you provides the best experience for your app. And contextually, you can also send back to your backend. We saw that it's very possible as a result of a push notification to send some information back. And you can contextually report what the user did with that offer. Was the offer tapped? Was visited after some time? Was never visited? Maybe the toast never arrived, and so on. And you can store all this data in your backend. This is all data that is user-specific. Note that now you're not wasting your time sending, storing device information. You're actually storing information that's relevant to your app. And then what you can do is that you can perform analysis on this data. You can update the tags given those analyses. You can find out that somebody is a food lover or that somebody is a vegetarian, for instance, without them finding out. You can label them like that without them telling you. And after you have that, after you have that information, you can retarget them with the correct offers. So this is a couple of things that were basically like, other issues in the notification hub space, but we really have no time. Everything is flashing at me right now. For telemetry, we do have the portal dashboard that we saw. All of the things that you see in the dashboard are available programmatically. If you want to access them, you want to provide your own dashboard, if you want to do monitoring and anything like that. For security, there are many different aspects of security. There is the device registration management rights. You want to make sure that to know who is able to create, delete, and read registrations. There are sending rights, and there are PNS credentials rights. Sometimes there are multi-tenant app that have a different different requirement for securities. We actually have some nice advanced features that I did not have the time to talk about tonight. But if you're interested in those things, we're able to provide different rights for people that are able to send and people that are actually able to access the PNS credentials. And of course, scale. The guidance for very high scale, and by very high scale, I mean like many millions, depends a lot on your scenario. So I cannot really say this is how you do it, because there are like so many different ways to send push notifications. There are something like Winter Olympics, hundreds of interest groups, or just simple broadcasts, or just one-to-one. For those things to really reach out to us, we're very, very eager to talk to you. But for anything that's like just a few millions, you shouldn't try to create multiple hubs or do anything fancy. Our architecture is already scaled to handle those kind of mobile scales. There are a whole bunch of resources, pricing, videos, take advantage of that. There are a couple of related sessions that I want to talk about mobile services. They will refer notification hubs for push notification. They will talk about the notification hubs in integration with mobile services. They are tomorrow and Friday. And we're over. I think maybe we can take some questions, hopefully. Let's assume that we can take some questions. Thanks. Yes? Can you use the microphone? Sorry, I can't really hear you.
When you guys sent from a client, when you sent out a push notification, I note that you said that it was within 2 minutes a notification occurs. And then you showed us some filtering based on time zone. So does that mean the local app has to manage the time zone?
Yes. So right now we do not have support for time zone in the service. So that's effectively a tag. And how it can be achieved right now is that basically your own backend has to schedule different notifications at different times. So basically you have to wait to send the notification when is 12 o'clock in, I don't know, Sydney.
Okay, so this is on demand. It is nothing due to like queued or schedule or anything like that?
No. We are working on those things, but it's not available yet.
Thank you.
Any other questions?
Relatively speaking, what's the reliability of the push notifications compared to, let's say, email? Actually being delivered.
The thing is that we rest on top of the platform notification services. They provide no guarantees. Now, they usually arrive. The thing is that there are some things, there is one main reason that makes them very different from emails. The thing is that an email, it's something that's permanent. Nobody is going to delete that email address. I mean, it happened, I think Yahoo did it like a few months back, maybe a year ago. There was a huge backlash. But basically, an email is permanent. Channel URI, a device token, is not. So effectively, when your app sees a device, it never knows if it's going to see it again. So after some time, the notification is just dropped. That is effectively what it is. And in general, if things are online and live and responsive, they arrive most of the time. Where I see most of the problems is when sometimes there are like, since every platform notification service has a slight different policy, usually people that come from one and go to another might set up things so that they do not work right away and they feel that the notifications are not reliable. So usually are platform-specific issues that can be solved. However, there are some fundamental differences that might not make push notifications reliable as email, for instance.
Using the push-to-pull pattern, you can achieve more reliable channels, which is what email clients do.
You can.
Applications to synchronize the offline session.
Yes. So basically, what is the proposal is basically to use to record on the back end if somebody has received the notification or not, and then make sure that they read it basically by poking them over and over again. That is definitely the pattern that we suggest if you want to achieve more reliable delivery.
I have another question. I
Yes.
mean, more questions. Considering I want to send push notifications to a specific user, I obviously want to secure all the data and values and keys and so on and so forth on server side rather than client side. But then again, there are push notification messages in the same applications that I might use publicly. I mean, the same message for everyone. And rather than scaling my backend services, I would rather save the credentials for those kinds of messages on my client side. So I don't have to handle high availability on my backend for public messages. What's the best approach here? Should I have two hubs, or how do I do it?
The thing is that you can use the same hub, but the problem is that the main problem is, do the two sets of tags ever conflict? So the thing is that if the notifications are either of type A or type B, and there will never be anything that is a mix of both, where you're going to say have a tag expressions that involves both, then it is safe to have like to do this kind of dual approach. But in general, we don't recommend it because it really requires a lot of discipline. I mean, you have to make sure that that is something we cannot control, and effectively you might start receiving duplicate notifications if the tags are not really separated. The two sets of tags are completely distinct, and you will never send one notification to both of those.
Yeah, moreover, if I would use the same hub, I would, in the end, have the keys inside my application, my client.
That is true. So basically, you have two ways. You have, if you want to go that way, you have to have two hubs.
Yeah. Okay.
But the thing is that, why do you feel that you're going to have more traffic? The thing is that every app has to register every time it starts. So since that is the case, why do you think that there's going to be more traffic? I think we're done. Sorry, we can continue offline.
Sure.
Thanks.